Okay, in this video we are going to be looking at question 12 from the WJC additional maths paper from June 2015. And this is quite clearly a first principles question. So, in order to find a derivative in first principles, let's have a look at the approach that we need to take. So we can say, I'll write it by here, so dy by dx equals the limit as h tends to 0 of f of x plus h minus f of x all over h. And the good part about a first principles question is because you should be knowledgeable enough about your differentiation that you know what the answer is before you do it. So if I did want to differentiate, so I know my dy by dx is going to be 2x minus 3. So I know what my answer is supposed to be. I just need to make sure that I can get there. So the first thing I'm going to need is every part of this formula. So I tend to look at the bits in brackets first before I worry about this limit. So I need to look at f of x plus h. I already know what f of x is. So my f of x is this expression that we're called y up above. So that's my x squared minus 3x. So my f of x plus h says instead of putting x in and getting x squared minus 3 lots of x, I'm going to put x plus h in. So I'm going to have x plus h by here and x plus h by there. So that will give me x plus h all squared minus 3 lots of x plus h. And this can be expanded. So this first bracket, x plus h all squared, should be one that you should learn because it will be there in every first principles question you do at additional maths. Is x squared plus 2 lots of hx plus h squared. And then the second bracket is expanded by negative 3. So minus 3x minus 3h. So this is my f of x plus h. Okay, now I'm ready to look at my formula. So again, I'm just concentrating on this bit in brackets because I have everything that I need. So I've got my f of x plus h. So I'm going to subtract my f of x and divide it by h. So my f of x plus h is x squared plus 2hx plus h squared minus 3x minus 3h. And then I'm going to subtract all of my original f of x. So I'm going to put it all in brackets because I'm subtracting the whole thing. X squared minus 3x. And that's all over h. And now I'm going to simplify. So if we're doing this right, everything in the brackets at the end will cancel out. So let's have a look. We've got an x squared minus x squared, which is 0. Negative 3x minus negative 3x will also be 0. So we will be left with 2hx plus h squared minus 3h all over h. Now, h is a factor of everything on the top line, so let's take it out. So h, lots of 2x plus h minus 3 all over h. And now the expression in the brackets on the top line, the 2x plus h minus 3, is being multiplied by h and being divided by h, so they will cancel out, which leaves us with 2x plus h minus 3. And then that can't simplify anymore. So at this stage, I'm going to start looking at the limit. So I'm going to actually find an expression for dy by dx. So therefore, my dy by dx, my gradient, is equal to the limit of what happens as this h goes to 0 in the expression 2x plus h minus 3. Now, if h goes to 0, that means any expression involving h will become 0. Well, the first expression, 2x, doesn't involve h. So as h goes to 0, nothing changes. That stays as 2x. The plus h, as h goes to 0, that will become plus 0, which is nothing. And the minus 3, well, it doesn't involve h, so as h goes to 0, that's still going to be minus 3. So the only term that's affected is that middle one, so we're left with 2x minus 3, which if we check, is exactly what we expected at the start.